Welcome back. In this video, we're going to try to do the following. F is continuous on AB. We assume that f of A is less than AB and f of B is bigger than B squared. We want to prove that there is some C in AB such that f of C is equal to CB. Here, to prove this result, we're going to use the intermediate value theorem. Okay, so here we know that if we have a continuous, it has to be a continuous function, let's say defined on AB, and if we can find, let's say this is A, this is f of A, and this is f of B. If there is some n here, that means n is between f of A and f of B. Okay, look at n here. So there is some c here, c between A and B. There is some c here in this interval, such that f of c is n. Okay, so this result is very important, and we can use it here to prove our result here. Okay, note that we have all the conditions, so f is continuous, but we have to use these two conditions here, okay, to conclude. Therefore, to start, we have to build a function. So we're gonna build our function here. Look at this c here. So if we call this function f of x is cb, and we use another function, so let g of x be f of x minus xb. Okay, and we have that f of x is continuous on AB, and x is continuous on AB. X is continuous on AB. It's easy to prove, and we accept that. Here we have the sum of two continuous functions on AB. Therefore, g of x is continuous. So g is continuous on AB. Okay. Now what we can do is we have to find our n. To find the n, we have to do some work. We're going to use the conditions that we have. So therefore, we're going to compute g of A and g of B. So we have g of A, it's f of A minus AB. Okay, and we have g of B, it's f of B minus B squared. Okay, so here let's assume that this is the this is A, this is B, and so g of A is f of A is less than AB. That means this is negative. So g of A is gonna be here. So this is g of A, and g of B is f of B minus B squared. So this is positive. So g of B, it's here. Okay, so therefore we can see that since g is continuous, okay, so there is some n. So here 0 is between f of A, sorry, g of A and g of B. So here 0 is my n here. So this is let me use another color. So 0 is gonna be our n. So therefore, according to the conclusion of the intermediate value theorem, there is some c such that what can I say, g of c is equal to 0, because this 0 is my n here. So this is the n. So the conclusion says that f of c, not this f of c is n. If there is an n between f of a and f of b, there is some c such that f of c is n. Okay, here my n is 0, and therefore I can find c such that c is in AB, c has to be in AB, such that g of c is 0. But I know g of c by construction is g of c is f of c minus cb. So here g of c is f of c minus cb is 0, and this is written in another way is just f of c is cb, and this is what we have to prove. So therefore we found c in AB such that f of c is cb. So the proof is based on constructing another function and using these conditions here, okay, and seeing that n in this case is 0. Okay, and therefore we have proved the result that we need. Okay, remember we need the continuity to apply the intermediate value theorem. If you see any errors or mistakes, please let me know. Thank you very much.